Hello everyone. Today is the 70th day of Leetcode 75 challenge. Let's begin with the 70th question. Question 1493. Longest subarray of ones after deleting one element. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given a binary array nums and you need to find the longest contiguous subarray that contains ones after deleting exact one element. Okay. So you have to basically delete one element from the array to get the longest subarray of it. Fine. And it has to be contiguous. What contiguous mean? The elements in the subarray appears consecutively without any gap, and you must delete exactly one element, meaning you remove one element from the array and check for the longest subsequence of one. Fine. And at finally, our task is to return the maximum number of consecutive ones in the array after deleting exactly one element. If there are no ones left after deletion, we return 0. Fine. Now let's understand the constraints. The length of the nums array will be from 1 to 10 to the power 5, and values would be either 0 or 1 in the array. Okay. So this is the question. We just have to give them the continuous subarray consisting of ones only. That's all. And it has to be contiguous. And secondly, it also mentioned in the question is that if there is no deletion happened, right, in complete array, there is no deletion happened, we just have to remove -1 from it. Basically, if the size of the array is n and there is no deletion happened, okay, so you would be returning n minus 1 otherwise, right? I hope you understood the explanation of the problem. Now let's move to the next slide. Let's understand the input output of the problem. So you have been given nums 1, comma 1, comma 0, comma 1, fine, and output is 3. How? So if you can see, if we remove this 0, our array becomes 1, comma 1, comma 1, and it is contiguous, right? Okay. So therefore the output is 3. And in this case, if you see, we have 1, comma 1, comma 1, but output is 2, right? But the length should be 3. Why it is 1, 2? As I said earlier in the explanation also, that if all the values in the array is 1, right, then you have to return n minus 1. That's all. I hope you understood this. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Fine. Now let's start. So imagine you are organizing a chain of lights. Let those be ones which are connected a few faulty bulbs which are zeros. So our goal is to make the longest contiguous stretch of working lights. But there is a catch. You must remove exactly one bulb, whether it is working or faulty. So let's build up an intuition taking this scenario. Fine. So if you take here, let's take this. Let's take 1, comma 0, comma let it be 1, 0, and 1, then again 0, then 1. Okay, let it be. Now, if you can see here, according to our understanding, what will be the longest sub array, right? It could be this of length 4, because if we remove this, then the length will become 3, right? Consisting of ones. And if we remove this 0, we will get contiguous one of size 2, right? Since we cannot remove both of these two, it is not possible, right? So this is clear from this example that these are the output. The output will be 3. Fine. Now let's build up an intuition to it. If I make it here, there is 1, comma 1, comma 0, then 1, then 1, then again 0, then 0, then let it be 1, comma 0. I have just taken a random array, fine. So what intuition comes to our mind? That okay, we know that we are allowed to remove only one element from the given array to make the contiguous subarray of length n consisting of ones, and we wanted the longest one. Fine. So what we can come up with is that we will iterate the array, and as soon as we get 0, now in this case we are just given a binary array 1 and 0, right? So it's a common sense that we have to remove 0 only. That is our obstacle. Okay. So this could be our faulty bulb in the intuition example. So we thought of removing this. Okay, we removed this. We are not considering this value anymore, and we moved ahead. Okay, now we know that we already have removed one element. So what we will take, what we will do, we will just take length of this. For now, the length of this is 1, 2, 3, 4. Okay, fine. Now what we can do again is that we can come back here and we can start again, right? We got 1 0 here, this one, and we moved ahead. Now again we encountered a 0. Fine. So we cannot delete it because we already deleted this 0. So we took these three ones. So 3 is smaller than 4, so we won't be taking it. Okay. Now we went back again and we started with 0 and we moved ahead, right? So the length will be 2 since we cannot take remove two zeros. So this 1 we will be taking. Then similarly, we will come here 1, the length will be 2 again. If we come here 1, then it will be 1 only, right? After that, if you see the maximum length after considering is 4. So here, if you can understand, let me make it as 0. Okay. So this is the thing. Now, what could be our intuitive approach to optimize it, right? Because the thing which we just saw here, it will take n square, nearly n square approach to solve it, right? So that is not an efficient one. So to build up an intuition which is efficient, what we can think of is that let's begin with the starting point, fine, and we keep on counting, right? As soon as we encounter a faulty bulb, which is 0 in this case, we just take the count of it. Okay, we have just taken one count. Okay, let me just date it. Let's take the count of it. That okay, let me write it here. That count is 1 right now because we took 1 0 in our consideration and we moved ahead. As soon as we reach here, we can see that okay, we can check the count. Okay, we know that count of 0 is 1, which means we have already removed an obstacle. Okay, which is basically a bulb in this case, right? So we cannot remove another one. So we can just take the length of the j minus I. By doing j minus I, we can take this length, right? That is an easy thing. Okay. Now what? We have to check for further values also, right? Whether we get the larger part or not. For that, what we do? We thought, let's keep our I here, or whatever variable we were taking, and just decrement from the left side. Why? Because if you find a faulty bulb, you realize you must remove one bulb. Fine. It can be the first faulty bulb or even a working light also, right? And so what we do, we remove this working light. Okay. And we again check the count. It is smaller. No use. Because till now the count is 1, which means we have already removed 1 0, right? Then we moved ahead again. Still it is 0. As soon as we reach this part, we make this count as 0. Why? Because now we will be considering this length, right? And this will be our new length. So this is what is explained in the intuition approach, that you begin at one end of the chain and count how many working lights are in a row. If you encounter a faulty bulb which is 0, you don't immediately remove it. You move forward while keeping the track of the position. Okay. Now again, if you find a second faulty bulb, you realize you must have removed one bulb. Now it can be the first faulty one or even a working light, right? To ensure the longest stretch of the working lights, what we decide? We decide to remove the earliest encountered bulb and continue counting. Now, why we are doing this? Because if we don't remove this basically 0 from our count, we won't be able to make our stretch. First and foremost thing, right? And intuitively, what comes into our mind, to make our stretch, to increase our stretch, we have to remove that 0 from our array. Fine. And for doing that, we have to come from back until unless we don't get a value which is equals to 0, and we decrease the count. As soon as we decrease the count, we can move ahead, right? Further investigating more values of 0 and 1, right? So at this way, at any moment, you you have only one removable, right? Keeping the longest functional stretch possible. Okay. I hope you're understanding what I'm trying to do here is that whenever we encounter a faulty bulb, we are just trying to take its count, increase its counts, which means we have taken the fault table. Now we will move ahead. Fine, that is good. But what happens again if we reach at some point and we get another fault table? There is only one solution left. We have to remove the fault table which we got before, right? That is the best thing which we can do. In this case, if we say, if we continue coming from starting till this one, we will the length will be 2. Okay. Now we started from here removing the bulbs and we came till 40 bulbs. Okay, we removed 2 bulbs, but since we need 1 as the longest array, right? So we remove this 0 and now our sub array will be starting from here, right? So we can take this in our consideration and the length of this is 4. So removing the 0 from the previous, I will say, sub array helps us to find a new sub array of some length consisting of new fault table. Fine. So if you can just pay attention to the part, what we're trying to do here. If you can see, first we created a window of length x, let it be x. It is done. Now we tried to increase this window till here, but we were not possible, but we were not able to do it because we cannot remove 2 zeros from to create the longest array, right? So what I did, or what we did, is that we thought of removing the elements from the back. Fine. And as we removed the elements, we got a new window from second index to the last index, right? And similarly, if we assume this array goes up to some longer point, there could be another array which starts from here and goes till here, right? Or there could be another array which starts from here and goes till this part, right? So if you can see the pattern and consider this sub arrays as windows, we are doing a task of sliding window here. I hope you're getting this point, right? We are just making a sliding window question or sliding window solution here because we created one window here till 1, but we tried to take in 0 also, but we were not able to, because, right? Then we created another window which starts from the second index to last index, and if the array is extended, we could take then more windows were created. So by doing this, or by taking the help of sliding window, at the time which we reach the end, we will have determined the longest possible illuminated section of lights. Got it? So the technique here which we are using from the intuition, I hope you understood. We are trying out to make sliding window technique, right? Let me remove this and give you a visualization that why how we came up to sliding window solution. I'm just drawing the arrays, right? Just for the visualization. Suppose this is an array. Okay, I will extend the array if needed. Let me remove this and make it on top. Okay. Let this be an array. Fine. So first answer you got in this subarray. Fine. And assume that somewhere here you had 1 0 which you have to remove to get a new set of ones to create a subarray. So as soon as you remove from here, so you created one more array, subarray till here, right? Let me extend this array again. This is the original array. Okay. Now till here you got, so you know that anywhere here there was another 0 which which you had to use, right? So from there you created another window till where you didn't encounter another 0, right? So you can see, right, this is a sliding window question and we're just sliding the windows towards the right side. So I hope you understood the visualization and understanding of the intuition why we are using sliding window technique first of all, and secondly how we arrived at sliding window technique, how we came to know why we have to use sliding window, right? We are just pushing the array towards the right side. That's all. Keeping in mind that once 0 is encountered, we take the count, and second time when another 0 comes up, we try to remove elements from the back until and unless this count value becomes 0 again. Fine. So this is a very simple, straightforward intuition. Nothing to worry about. Okay. Now I hope you understood this intuition. Now let's move to the next slide. Before going to the approach, let's understand what is sliding window concept in more deeper meaning or in more deep depth, right? So sliding window is a powerful technique used to efficiently solve problems involving contiguous subarrays or subsequences. I hope you understand what is subarrays, right? If this is a subarray with some values, the subarray for it will be x, n, z. We follow the relative order given in the original array, but it may be continuous or it may not be continuous, right? And same case in the case of string also. Now, how it works? First, we define a window, usually a fixed size of k or dynamic size. Window could be a dynamic size also, or it could be of fixed size also. Uh, that could be derived from the question itself, what the question is asking, over a part of the array or string. Now, we just start by calculating the result for the initial window. Now, whatever the calculation has to be done for a particular window, like adding the complete value, taking the average of those of that window, taking the multiplication, or anything whichever is asked in the question. Then slide the window one step at a time. Add the new element coming to the new window, which is in the right side, and removing the old element that is leaving the window, which is from the left side. Now keep updating the result while sliding. So it goes like this is the array, and this is one window from start to k size. Now your task is we will add new element, that this will be the new element added, and you remove the last element, that this be the last element removed. So our array just moved by one, right? This is how it goes. Now, why is it efficient to use? Now, instead of recalculating the result from scratch every time, we just have to adjust the result using a new and outgoing element. Just requires O of n time in that. And the total complexity becomes to O of n instead of O of n into k, which you get from brute force approach. Brute force approach is basically you start from I, go till n, k, this is the size. Then again you start with I plus 1, and again you go from k times, and this is how you go, right? So this boils down our complexity to O of n. Now let's move to the next slide. Now, variations of the sliding windows. Now, where could you use the sliding windows and what could be the variations of it, right? So let's understand that also. If it is a fixed size sliding window, if the size is given to you, it is fixed that it will be a k of suppose size is always 5 and it won't be changing. So just have 5 and sliding one step at a time and adjusting the result. Use cases could be maximum, minimum, or sum of fixed length subarray. Example is maximum sum or average of subarray of size k. Now there could be a two pointer variation also. The left and right pointers define the window here, or expand or shrink based on the conditions, like finding pairs, minimum, maximum range. Example could be container with most water. We solved this question in our previous videos. Please look into those also regarding the two pointer variation, container with most water. The third type or third variation will be monotonic sliding window. We use a DQ to keep elements in order while sliding. DQ is a data structure in a nutshell is that we can push and pop from back, push or pop from front. Right? This is DQ. The use case could be maintain a sorted or maximum minimum values in a window. Maximum in each subarray of size k. Whenever you have to maintain a sorted maximum or minimum values in the window, we have to use DQ, and this is called a monotonic sliding window technique. Now the fourth variation will be dynamic size sliding window. We expand the window until a condition is met, shrink if it is violated. Now, expansion of the window is done from the right hand side and shrink is done from the left hand side, right? If we expand it like this, then you shrink it from the back this way. The use case is longest or shortest substrings satisfying a condition. Example could be of the problem longest substrings with k distinct characters. Now the fifth variation will be circular sliding window. Window wraps around an array boundaries like a ring. The array becomes a ring. Fine. Use case would be sum or minimum maximum in a circular arrays and maximum sum of circular subarray. So these are some of the most commonly used variations I have defined here of the sliding window technique. I hope you get a gist of sliding windows and their use cases and examples of the problems I have mentioned here. If it is good to you, please go and look at these examples and you can understand how these sliding window techniques are being used. Now let's move to the next slide. Now, where sliding window is used, okay, in a nutshell, if you see in subarray subsequence problems, like having maximum, minimum, average of size k, longest, shortest subarray satisfying a condition. In string problems, longest substrings without repeating characters, longest substrings with k distinct characters, and minimum window substring. Now, pairing and range problem also. Container with most order sum of two elements closest to zero, number of subarrays with sum within a range. Now, frequency counting using set or hash map. Longest substrings with k most distinct characters, find anagrams in a string. Now, I have given you the sliding windows where it is being used here, and these are some of the examples or name of the problems. I have given you the names of the problems and examples where this sliding windows is being used. It is just a gist. So you could go and look at this the problem and understand that how the sliding windows are being used in this kind of problems. I hope you understood the concept of sliding window, how it works, what are the variations of sliding windows, and what are the problems you could look into it. Just get the understanding and gist of sliding window and where the windows are being used. Now let's move to the next slide. Since we get the intuition of the problem, let's look into the approach, how we're going to solve it. So as I discussed about the intuition, I have tried to keep the approach in the systematic manner only. Okay. For a sliding window technique, either you can use a for loop directly, but since it is a dynamic sliding window question, we will be reading two pointers. Here, check one is basically right pointer, which expands the window, right? Expands the window, basically it goes in the search of ones until unless you encounter a zero. And remainder zero is a left pointer, which shrinks the array until and unless the count of zero becomes, the count variable becomes zero, right? Basically, we remove the previous taken zero from it. So we can take the new zero in the new subarray, right? Let's remove this. Right? And count of zero is just keeping a track of the zeros inside the window. That's all. And answer will store the maximum, the length of the ones found consecutive subarray or contiguous subarray, and this stores the length of the array. That's all. This is a declaration of the variable for our approach. Nothing else. Okay. Okay. Now let's go with the right pointer, which is a check. Fine. Now what we are doing here? We are iterating through the array using check one, and as soon as we encounter nums check one index as one, simply expand the window by moving check one to forward. Simple. Basically, I plus plus. That's all. And if it is zero, right? Now we have to check for two things. Have the count zero variable is greater than one, or is it zero? So increment count zero because we encountered zero. Okay. But we need to ensure that we delete exactly one element, meaning at most zero should be remaining in the window. Now, what is this? Is this saying is that if nums of check, like check one, is zero, you have to also keep in mind that count of zero variable is less than one, right? Then only we can increase the count zero and move the j plus plus, basically the check one. Fine. And why we're doing this? Because we need to ensure that we delete exactly one element, right? Meaning at most one zero should remain in the window. That is the reason why we are not making count zero greater than one, right? Now let's move to the next slide. Now, while shrinking the window, left pointer, okay, here, as I explained before, if the count of zero becomes greater than one, it means we have more than one zero in our window, which is invalid. We move remainder zero forward until the count of zero becomes one or less than one, right? For example, if this is the array and we are standing here and count it becomes greater than 1, right? So I have to reduce the size to here so that the count again becomes 0 and this gets add up and it becomes 1 again, right? This is one thing. Okay. Now let's see. If nums of 0 is 0, we decrement the count of 0 because you are moving past as 0, right? Remove it from consideration, that's all. Basically, as I told you, if 0 is here, so new window will be starting from here, right? For example, if you encounter 0, okay? So we have to exclude, discard this 0. That's why we will be incrementing rem 0, right? And why we're doing it in a brief manner? To ensure that only one 0 is removed while maximizing the length and to ensure that there is only one 0 present in the subarray. Now, at every point, we will keep on considering the maximum check of the length. This calculates the current value window size and updates the answers if it is larger, right? Finally, we return answer minus 1 because this is the important part. We must delete exactly one element. Since we need to delete one element, we remove one from the total length. Now, if you take in consideration, 0 is here, right? And j is somewhere here, and I is somewhere here. If you can see here, we are just doing j minus 1, j minus I, which is check 1 minus rem 0. So it gives us length 3, which includes 0, fine. So therefore, at the end, we do answer minus 1, so that this one value is removed. So basically, the 0 is removed. And also, if you can see, if if you remember the explanation of the problem, if the array contains only one, right? So answer is 2. Why? Because at the end we have to just remove one element from it. That's all. Now let's move to the next slide. Now how sliding window is helping us? Let's take a brief on it. When we encounter a 0, we allow only one deletion, right? Ensuring we stay within the problem constraints. First thing. Now second thing is this: when we exceed one deletion, we shrink the window from left instead of recomputing everything, right? Basically, in the previous explanation, as I said you, that once we find this, we won't be coming back and calculating it again, right? Won't be coming back and calculating again. It's a tedious task. It will take some n-square approach, right? Inefficient. So to avoid that, what we are doing, we're using sliding window, right? Yeah. At every step, we track maximum survival length dynamically, avoiding recalculation, right? And we update the count only when elements enter or leave the window, basically 0, preventing redundant work. So I hope you understood the approach discussed here. Now let's move to the next slide. The code is exact copy of the approach discussed. Let's understand it line by line. Fine. So this is the left pointer. This is the right pointer. Count of 0 as we declared about the variables, and this is the answer we will be storing. This is take the length, nums length. Okay. Here is the main logic. Check 1 less than n. Why we are doing this? If you can understand, keep in mind that check 1 is the right pointer and remainder 0 is the left pointer, right? This will be always behind the I. Therefore, there is a chance that I will end up early, right? That's why we are taking this as right pointer as the main execution falsify reason or the condition to terminate. Now, if nums of check 1 is 1, we increment 1, that's all, expanding the window, right? We're expanding the window. Let this be the end. If check 1 is 0, so we increment, no issues. We increase the count also, right? This is done. Now, within this loop, if we check that if count of 0 becomes greater than 1, basically you encounter another 0 here, you encounter one 0 here. So what you do? So before coming to here, we say we increment nums of remainder of 0 plus 1 from here, the right left pointer, right? Also, if we find the nums of remainder 0 as 0, we decrement the count back to 0, which means we have discarded that 0 from our array, right? This is discarded. And after every iteration, we just try to take the length, check 1, remainder 0, right? And we remain answer minus 1. So that is the complete code. And now let's look at the time complexity. Why it is O of n. If you can see, we're just iterating the array one time, right? And there is no coming back and going forth again and again, right? It's just straightforward moving ahead. That's why, and the length of the array is n, so complexity comes out to be O of n. And space complexity is O of 1 because we are not using any list or data or any kind of data structure to store the large values. We're just using variables which take constant space. That's why the space complexity is O of 1. So I hope you understood this code explanation of the code solution. Now let's move to the next slide. Now since we have the understanding of the code, let's look at the dry run of the example. Okay. Now let's understand the dry run. How the dry run works, right? So this is 1, 0, 1, comma 1, 1, 0, and 1. Right. Now let's take I as the left pointer here. 0 starts from 0, and let j be the right pointer here. Fine. This will expand the window, this will shrink the window. Fine. There is one variable, as I remember, which is count. We took count 0. Okay. And there was one variable answer, right? And at the end we were returning answer minus 1. Fine. Let's keep this in the box here. Okay. Now I standing here, let jv here and I be here. Now in the first field itself, we're getting j equals to 0, right? Which means we have to increment the count 0 part, and we have to take the difference. J minus I gives me 0 only, so I will just store 0 and increment the j. Now j minus I gives me what? If I index this, so it will be 0, 1, 2, 4, 5, 6, 7, 8. Okay. Now putting j here, 1 minus 0 gives me 1. So yeah, this answer is greater. So we'll store it. When j moves ahead in the 2th index, it is 1 again. So we will take this, and 2 minus 0 gives me 2. Fine. Again we move to 3, gives me 3. 3 minus 0 gives me 3, right? Because at answer we are doing j minus I, right? Again we move to here. Now here you can see that it is 0, right? So if it is 0, what we will do? We will check the length again. The length is what? 4 minus 0 gives me 4, right? But we will be having doubt that no, the window 4 minus 0, it's 4, right? But as you said, the window should be of length 3. Right? That's why we were doing answer minus 1, if you remember, right? So we'll come to that. We will come to that part. But before that, let's do the dry run. Right now, our maximum answer is 4, right? And since I is also 0, we will decrement the count of 0 here to 0 and increment the I. And since j starts from here and it is 0, so it will increment by 1. And we will take the difference of 4 minus 1, which is 3. And of course, that is smaller than 4. We cannot take that. And again, j comes again to 5. Now, what is 5 minus 1? It is 4, right? We already have 4, so we cannot take that. Again, we came to the 6th index. It is 6 minus 1. It is 5, right? 5 is greater than 4. So we store 5 here. Great. Again, we moved ahead. Now, it is 7, right? 7 minus 1 gives me 6. Okay, it is greater than this. We store it. Now, the main part comes that since I encountered 0, right? So we cannot take this array. So what we do? We increment I till or while count is greater than 1, right? So we increment I again incremented. And in each case, we had student distance. I'm not calculating that right now. And we reached here again. Okay, now, since we reached at 0, we decrement the count, right? And we take the difference. We increment I and we take the difference. What is difference? Difference is that 7 minus 5, it's directly 7 minus 5 is 2, right? It is smaller than the previous, which we had 6. So j gets incremented again to 8, and 8 minus 5 is 3, right? which is less than to 6. So we have 6 as the output stored in the answer, but at the end we were doing answer minus 1, right? As I made you save it here. 6 minus 5, 6 minus 1 gives me 5, which is our answer. So basically, at the end, why we are doing minus 1 is that, again, I will repeat it to you. Then our J was standing here at 7. I was standing somewhere here, right? This window. And in this part, we had one 0 included within our subarray. And we were taking that size or that length. That's why at the end we have to do minus 1. Implementing that, we have removed that particular value from the subarray, right? Even if the dry run would have been like 1 comma 1 comma 1 comma 1, and I would have been here and j would have been there. What would have been length? 0 1 2 3 4 minus 0 gives me 4, right? But the answer would have been 4 minus 1 3, because you have to at least remove one element from it at most, right? Or at least whatever it is. So I hope you understood this diagram. Now let's move to the next slide. Now, since you are familiar with the problem and the solution, let's move to the lead code and code the solution. As we discussed, remembering 0 or M0, this is a left pointer, and check 1, this is a right pointer. Count of 0 will keep the count of 0 in the particular window, and answer of 0. So the answer, and so the length of nums. Now while check 1 is less than n, and if check nums of check 1 is 1, check 1 is incremented to expand the window. And if nums of check 1 encounters a 0, right, we increment count of 0 by 1, and also check of 1 by 1, right? Now, while count of 0 is greater than 1, if nums of rem 0, we're checking that when we're shrinking the window, and if the particular index comes out to be 0, we have to decrement the count, which basically says that we are discarding the value from the previous window so that we can increment a new 0 to it, or add a new 0 to it. And this will take the difference of the length. Okay, this is rem 0. Now, here we will be getting an output, for example, 4, right? And consists of 1 0. So to get the output corrected one, we have to decrement 1 by it so that we remove that particular element from it. That's why. Even if the complete array contains the ones in it, there also we have to remove one variable from it, right? Or one data from it. So our code got submitted. Now let's submit the solution. It has been accepted. Now, code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.